Hey, feeling good, like I should. When in dark, I walk around the neighborhood, feeling blessed.
Alrighty, let's take a look at the closure problems. These are the types of problems that you're going to have to be able to solve on the test that you're going to take today. And problem number one, actually, I didn't even realize this. This is one of the problems from the closure homework. So I need to go through this again, the idea, but I will just briefly. The idea that trying to find the area of this complex shape, if you were to break it up into more recognizable parts, you could chunk this into two different rectangles where base times height tells you or gives you the area. And so 18 times 6 is 108, 29 times 9 is 261. And so the sum of those two areas is the total number of square meters that would fill the entire shape. So that's 369 square meters. And then filling in, you had to find these dimensions here to figure out what the perimeter is, and you just add up all the different sides and you get 88 meters. Consider the parallelogram at the right. What's the length of the base? Well, it's 6, right? I think I might have written that in there. Hopefully that's in your, hold on for a second. Let me just pause for a second. Okay, I just wanted to verify. If something got cut out here on this software to where it didn't show that this was supposed to be 6 units across, so that's why I wrote it in. So the base is 6 units. The height is the distance between the base and its parallel side on the other side of the parallelogram at a right angle. So this must be measured as a right angle. You can't measure this side and call that the height. Okay, so the height is always perpendicular to the base. That's the rule. So this is the information is given. Luckily, we don't have to use any extra math to try and figure out what that dimension would be. So to find the area, parallelograms, that's the basic formula, is base times height, right? Rectangles, we think of it as a rectangle formula, but a rectangle is a parallelogram. So you multiply base times height, and 6 times 3 is going to give you 18 square units. So if you draw a rectangle, it would have the same area, and the height of the rectangle is also going to be one of the sides of the rectangle. So this is what that rectangle would look like. And now, what is the area of this shape below? All right, so this is a perfect example where no one is going to come up with any kind of a formula for that kind of a shape. So you have to break it into its various parts. So here we've got 2 triangles. So I've labeled this triangle 1 and triangle 2, so that when you're seeing the work, you see how those are displayed over here. And then we've got a rectangle, and we've got, this isn't really a square, sorry, it's 6 by 7. So that's a second rectangle, but whatever. It's one that looks more like a square than that one. So to find the area of this would be 8 times 11, which is 88 square units. This would be 6 times 7, which would be 42. So you combine those, they would make 130. And then the triangle formulas aren't base times height, it's 1/2 times base times height. So this is 8 and this is 6. So 1/2 times 8 times 6 is half of 48, which is 24. This is the distance from here. That was not really clear. I apologize for that. But we know this is 7, and this shows a 9, so that means this must be 2. So this is a triangle that is 1/2 of 6 times 2, which is half of 12, which is 6. So you add those together, and you get 30. So the total number of square units that would fill in that entire shape has got to be 160 square units. I promise you I'm not going to have anything this complex on the test. Oh, by the way, had you chosen to, you could have broken this up into 2 parts. You could have had this rectangle right here. I'll just put a big R for the rectangle. And then this shape is a trapezoid. So if you had used the formula for a trapezoid for this part and the formula for the rectangle for that part and added them together, you would have also gotten 160 square units. All right, now for probability. And I think what I'm going to do here is I'm just going to give you the basics Whether or not these are experimental or theoretical probability comes down to whether or not it is mathematical or whether or not we are keeping tabs on an experiment. Okay, so for this first one, you got 24 crayons, and looks like 4 of them are green. So the probability of choosing a green is 4 out of 24, which is 1/6 probability. That's theoretical because it's based on the actual numbers. A spinner is divided into 4 equal sections. What is the probability of spinning an 8? Well, one of those 4 sections is an 8. So that would be 1/4, and that's once again theoretical. A fair number cube has 6 sides, right? Tyler tossed it 40 times, and 26 showed an even number. So this part, the probability of it being an even number, is experimental. However, theoretical probability of getting an even number would be 1, 2, 3 out of the 6, which would be 1/2. And then Sarah is at a picnic and she reaches into her ice chest without grabbing to grab a soda. These are the actual numbers of soda in the ice chest. So if 12 out of the 36 are fruit punch, that means 1/3 of them are fruit punches, which is theoretical because we're basing it on the numbers. And now for the last part, being able to use a giant 1, what do you multiply times 3 to give you 15? Multiply 4 times that same number, you get 20. So the giant 1 is 5/5, and the missing numerator is 20. Okay, so take a look at all those. Pause if you need to. If you have any further questions about any of those, I'd be happy to answer them. But actually, these all, I think, came off of I think this might have been one of your assessments, all of these problems. So if you have any questions, please let me know. Otherwise, let's move on to the chapter test.
Hey, feeling good, like I should. When in dark, walk